Every time you open LinkedIn, the page silently fires between 6,000 and 7,000 requests at your browser, one per Chrome extension on a hard-coded list, and records which ones are installed. Then it asks your WebRTC stack for your home network's local IP address, even if you're on a VPN. Then it walks your DOM. Then it collects 48 other device attributes. Then it encrypts the whole bundle with RSA and attaches it as a header to every subsequent API call. You did not agree to this. You cannot see it happen. And no, turning on a privacy extension does not fix it. This is what got named BrowserGate in April. The technical details are interesting. The architectural lesson behind them is more interesting. Quick disclosure for the room, Renaud Deraison, who wrote the Bromure browser we're going to talk about in a minute, and the real Ron Gula worked together at Tenable. Renaud did the engineering on Nessus. Ron did the engineering on the product that became Tenable's enterprise platform. So Ron has known Renaud's work for a very long time, and he has opinions. That is not why BrowserGate matters. It matters because it is a clean example of a thing that is true of most of the consumer web, not just of LinkedIn. LinkedIn got caught doing this at scale with a level of engineering polish that is hard to ignore. Most of the other big sites are running a sloppier version of the same playbook. The specifics of the LinkedIn case are documented by a European LinkedIn users group called Fairlinked, verified independently by 404 Privacy, picked up by the Next Web, and litigated, unsuccessfully so far, by a sister organization under the EU's Digital Markets Act. LinkedIn calls the reporting plain wrong. Users running flagged extensions have had their accounts suspended, which is the most direct evidence that the data is not merely collected but actively used. Two mechanisms running in parallel. The first is an active extension scan. LinkedIn ships a hard-coded list of over 6,000 Chrome extension IDs. For each one, the page fires a fetch request at a known file inside that extensions package, the manifest and icon, something every real extension exposes. If the fetch resolves, the extension is installed. If Chrome rejects it, it is not. A stealth variant schedules these probes through the browser's idle callback API with staggered delays so they don't flood the network panel. The second is what LinkedIn calls spectroscopy, a passive walk of your DOM looking for Chrome extension URL references, which catches extensions that inject content into the page and may not be on the hard-coded list. Then the fingerprinter, Canvas, a hidden image drawn with specific text, curves, and colors whose pixel values depend on your GPU driver and font rasterizer. WebGL is 65 plus parameters describing your graphics stack. Audio context, a signature derived from running silent audio through the oscillator, exploiting tiny floating point differences in the audio hardware. WebRTC, which the browser asks for local IP enumeration as a side effect of discovering network routes. Hardware and locale, CPU cores, device memory, screen resolution, time zone, language, battery level, installed fonts, touch support, 48 attributes in total. All of it combined into an encrypted blob attached as a header to every subsequent API request. LinkedIn's internal names for this are APFC and DNA for Anti-Fraud Platform Features Collection and Device Network Analysis on a single page load. This is where the conversation usually ends with a paragraph about installing Canvas Blocker and turning on Firefox's Resist Fingerprinting mode. That advice is not wrong. It also misses the load-bearing wall. Even if you blocked every single one of those 48 signals, every canvas blank, every WebRTC disabled, every font list randomized, your browser still has one cookie jar, one saved passwords vault, one extension list, one history file, one logged in session set, one IP address at the network layer. Everything you do on the web comes out of that single identity. A fingerprinter that cannot read your canvas can still tell that the person who logged into LinkedIn and the person who logged into Facebook and the person who checked their health insurance portal all came from the same browser instance. And that cross-site joining is where the money is. VPN on top, one exit IP, still one cookie jar. The VPN changes the shape of your fingerprint. It does not split you into multiple people. The fix, if there is a fix, has to be structural, and that is the argument Bromure is making. Bromure is a macOS browser for Apple Silicon. It's free, open source, and written by Renaud Deraison after he left Tenable. The premise is that the browser, the most attacked piece of software on your computer, parsing untrusted HTML and JavaScript and WebAssembly from the open internet thousands of times per day, should be something you can throw away. And not metaphorically throw away, literally throw away. Every browser window in Bromure runs inside its own disposable Linux virtual machine, booted via Apple's virtualization framework. When you close the window, the VM is destroyed. Cookies, history, any malware that slipped through a zero-day, cached trackers, clipboard data, all of it goes with the VM, gone. There is nothing to clean up because there is nothing left. Renaud built the first working prototype in about 2 weeks. Leaning hard on AI coding tools, he also made a deliberate decision not to raise venture capital for it. Both of those choices are relevant, and I'll come back to why in a minute. Because every Bromure window is its own virtual machine with its own kernel network stack, the VPN belongs to the window, not to the whole browser, not to the whole Mac, to the window. You can attach a Mullvad endpoint in Sweden to your LinkedIn profile, a Proton VPN endpoint in Switzerland to your Facebook profile, Cloudflare Warp to a random links profile, and nothing at all to your local banking profile. All at the same time. Same Mac, same Bromure app. LinkedIn sees the Swedish exit, Facebook sees the Swiss exit, the bank sees your actual home connection. None of them has a clean way to notice they are looking at the same laptop, because at the network layer, they are not looking at the same laptop. They are looking at 3 separate Linux machines with 3 separate routing tables that happen to live on the same Mac. The per tab VPN panel takes Cloudflare Warp for the one-click path, a WireGuard config for any provider you already pay for, or IKEV2 for a corporate VPN. The VPN runs inside the VM, which means even the guest Chromium process inside the VM does not see your real IP. There is no leak surface. BrowserGate's local IP leak comes from WebRTC. WebRTC is the browser's real-time calling API built for browser-to-browser video and audio. As a side effect of how it discovers network paths, it can be asked to enumerate your local network interfaces, which is how LinkedIn learns that your router handed you 192.168.1.47. Bromure turns WebRTC off by default for any profile that does not have both webcam and microphone enabled. The launcher passes 2 Chromium flags, one that blocks non-proxied UDP in WebRTC, one that enforces the permission check, and loads a small extension called WebRTC block that replaces the RTC Pure Connection constructor with a no-op stub. That last part matters because a determined fingerprinter can still instantiate RTC Pure Connection and observe its behavior. The stub makes even the constructor fail. You do not toggle any of this. There is no checkbox for WebRTC in the settings panel. It is derived automatically from the fact that you have not turned on webcam or microphone for that profile. The moment you do turn those on, because you actually need a video call, WebRTC comes back. The setting is on only when you need it, which is closer to how the web was supposed to work. 2 honest caveats. 1. If you sign into LinkedIn with your real name, LinkedIn knows it is you. Isolation does not make you anonymous to services you voluntarily log into. What it breaks is cross-site identity joining. LinkedIn can't confirm with Facebook that you're the same device. And passive re-identification between sessions. Those are real wins. They are not anonymity. 2, Bromure cannot stop LinkedIn's page from running the extension scan inside a Bromure VM. What it can do and does is make the scan's results uninteresting. By default, a Bromure profile has no Chrome extensions installed other than Bromure's own internal ones. The page probes 6,000 IDs. Nothing comes back. The 48 attribute fingerprint is still collected. But it identifies one disposable VM whose cookies and IP do not overlap with any other VM you run and whose existence ends when you close the window. That is enough to defang BrowserGate as a cross-site correlation tool. It is not pretending to hide you from a service you logged into. A minute ago, I said Renaud wrote the first Bromure prototype in 2 weeks and deliberately did not raise venture capital. Both of those are the tail end of a longer story, and the story matters because it tells you what kind of software this is. Renaud was 15 years old when he wrote the first version of Nessus in 1998. His machine had 56 megabytes of RAM, which is why the plugin architecture he designed is as obsessively resource efficient as it is. That plugin architecture, the thing that lets you ship new detection logic multiple times a day without releasing a new binary, was essentially CI/CD years before anyone had coined the term. Every security product that ships frequent detection updates today is running the same pattern Renaud drew on a napkin when he was a teenager. 25 years on, Tenable, 2 IPOs, a whole generation of vuln management tooling, the 3 vulnerabilities he says he'll never forget. WannaCry, where he shipped 20 plugin releases in a single day chasing variants. Heartbleed, which literally bled server memory back at the scanner and nearly melted Tenable's SaaS infrastructure under the load. Log4Shell, which he worked through while recovering from a COVID vaccine. Log4Shell pushed Nessus scanning traffic from around 500 requests per second to 5 million requests per second at peak, a number that told him, incidentally, just how widely Nessus had been deployed. After all of that, he sat down and decided that the unattended attack surface left in enterprise security was the browser, and that the browser needed a different shape. There are 2 things from the Rev and Carr interview that I think matter most for anyone watching this video. One is Renaud's take on AI as a coding force multiplier. His rough estimate is that writing Bromure today made him about 1,000 times more productive than he was writing C by hand for Nessus in the late 90s. Not because AI is magic, but because a technically strong engineer who knows how to prompt well gets leverage right now that used to require a 10-person team. The second is the line that sits underneath the whole project. Quote, "The value of software is going to zero, not the cost," he clarifies, the terminal value. If raw software is approaching zero, then the thing that differentiates a useful product from a commodity is not the code, it is the architecture, the trust model, the shape, which is why Bromure is interesting even when you subtract all the marketing copy, because it's an architectural bet from someone who has been right about the architecture of defensive tooling for 25 years. One more quote from the interview, because it's the honesty moment. When Mehul asks why Renaud didn't raise $20 million to turn Bromure into a venture-backed company, Renaud says, quote, "I did it in 2 weeks. So anybody can do it in 2 weeks, really. I'm not special, I just prompt it the right way, and it's not super hard to reproduce it." That is a load-bearing statement about where the leverage is in 2026, and it is not the statement you usually hear from a founder with his resume. The full interview with Mehul Revankar, another former Tenable engineer who watched both Renaud and Ron scale the company in the early 2000s, goes into all of this in more detail, including the engineering decisions behind the per VM model, the MIT license choice, and the built-in MCP server. Link is in the description. I am trying not to turn this into a sponsor card, but there are a few specific features that matter for the LinkedIn use case. AI phishing detection. Because LinkedIn phishing, fake recruiter messages linking to credential harvest pages, is a massive category. The media panel lets you turn webcam and mic off per profile, which automatically kills WebRTC as a side effect. File downloads can be disabled per profile while file uploads stay on, so you can still upload a resume to a job posting, but a compromised page cannot drop a malicious payload onto your Mac. And the advanced panel encrypts the persistent disk using LUKS with a key stored in the macOS keychain, which is a reasonable paranoia level for anything social media adjacent that you want to survive reboots. The built-in MCP server is worth a note of its own. It means you can hand a specific authenticated profile, a logged-in LinkedIn account, an internal SaaS dashboard to an AI agent like Claude Code, and the agent can act inside that profile without ever touching your host credentials or your other profiles. For anyone thinking about agentic web automation, that is a very different threat model than handing an agent the keys to your whole browser. BrowserGate is a good symbol for something that is true of the consumer web generally, and it is getting worse. Ordinary browsers cannot push back meaningfully against this class of surveillance because their entire architecture is built around a single identity per browser instance. You can install extensions to mitigate specific leaks, and you should. But the structural answer is a browser where each tab is its own computer with its own network, its own privacy surface, and its own ability to end. Close the window, and whatever data LinkedIn's scanner collected, whatever correlation cookies attached, whatever fingerprint they computed, all of that is attached to a Linux machine that no longer exists. That is the whole shape of the fix. It does not depend on LinkedIn agreeing to stop. It does not depend on the Digital Markets Act. It depends on the browser being a different shape than the one that came pre-installed on the laptop you bought. The link to the full Bromure blog post is in the description, along with the link to Renaud's interview with Mehul. If you want the technical details on the 6000 extension probe and the APFC pipeline, the blog post is worth the 10 minutes. 11 days warning before a CVE is a gift from the last episode. And a browser identity you can throw away is a gift from this one. It would be a shame not to unwrap either of them. And now, before I let you go, 3 browser security jokes. Because if you can't laugh about your privacy being harvested, what can you laugh about? First one, I told my browser to forget my passwords. Now it's acting like my ex. Yeah, it remembers everything except what I actually want it to forget. Second one, LinkedIn fired 6,000 requests at my browser to figure out who I am. Meanwhile, I've been on the platform for 10 years and still don't know what I do for a living. Third one, a VPN, a fingerprint blocker, and a disposable VM walk into a bar. The bartender says, "Sorry, we don't serve your type here. We already know exactly who you are from your canvas hash." Thanks so much for watching, and remember, close the window.